Hey there, folks. How you doing? Today we're going to talk about weather. Now, as you probably know, weather can be an entire semester. Heck, weather can be a doctorate. So today, despite my snappy little subtitle here, we're really just scratching the surface. Okay, there's so much more to talk about, and well, let's just see what we can talk about, okay? So, what is weather? Weather, simply put, we can say is the condition of the atmosphere, and typically, when you're asking about the weather, when you're measuring the weather, you're looking at three aspects: whether or not it's windy, what the temperature is, and if it's raining or snowing, etc. And you may have your particular order of interest. I suppose temperature is probably first for most folks, and then precipitation, and then wind. I'm not sure why I chose this order, but it seems to be in reverse importance, maybe. But these are the three aspects that we usually measure when we talk about the weather. Climate. You may have heard of the word climate. People talk about climate change, a tropical climate, or a arid climate. I want to go to a better climate. We use the word a lot. What the heck does that mean? Is it the same thing as weather? Is it different than weather? It's really a measure of a function of time. Okay. Climate is big picture stuff. Average weather over approximately 30 years. I know I got this number somewhere, and I'm not sure why they put the approximate in there, but the idea is it's decades. Okay. It's really easy going back to climate change to say, oh, geez, see, these last couple winters, they were really warm, or they were really this or really that, or the summers were this or that. But you've got to look bigger than a couple years when you truly want to talk about climate. Weather, on the other hand, is short term, okay, day to day. We say that the average of the weather over a long period of time would be described as the climate. So why does the weather change? It'd be nice if it could just stay sunny and warm with puffy blue clouds all the time, right? That's my ideal weather at any rate. You might have a different choice. But why does it change? Well, the wind moves different air masses around. And an air mass, just think of that little puffy cloud that I was just thinking about. It's tough to think about air. And when we have these discussions in this chapter, you look outside, there's no boundaries. Even if you were to see these fronts that they talk about on the weather forecast, it's oftentimes hard to tell when one front ends and another begins. Yeah, there are certain things. You might see a bank of clouds or something like that. But with the air itself, there's no boundaries. So when we're talking about it, if you're doodling along in your notes here and we talk about an air mass, feel free just to draw a little puffy cloud there, okay? So different air masses moving around change the weather. And those air masses have properties, okay? How warm or cold are they? How much water vapor is inside of them, all right? And then on top of that, we have the fact that the Earth is not always heated in the same way because of the tilt of the planet, because of the way we move around the sun. Sometimes we receive more direct energy than other times, and we've talked about that during the seasons conversation. All right, well, so what is air? Air, loosely defined here, is a collection of gases that's held to the Earth by the Earth's gravity. Pardon me while I capitalize Earth here. All right, collection of gases held to the Earth by gravity. All right, and again, this is sort of a relative term. You could go to any number of planets that have gases held to their surface, and you could probably call that air as well. But for us, it means something very specific. For us, air means mostly nitrogen, a little bit of oxygen, and a handful of other things smattered in there for good measure. Our air is primarily two elements, okay? And again, you've heard this before in class, but just a reminder now. Now, a new concept, well, no, I think we've even talked about air pressure already, but we'll just, a new concept is that, maybe as of this semester it's a new concept, is that all these elements, these gases, this air, actually has mass or weight to it. All right, remember, weight is gravity's effect on an object's mass. There's mass to these things. They are molecules. They have mass. So the fact that they exist, the fact that air is there, okay, means that it is exerting a force, a pressure down on you, down on anything that is in the air. And we've referred to that in the past as air pressure, of course. But we didn't always feel this way. I was just doing a little bit of reading about barometers, believe it or not. And they were really coming up with all kind of interesting, let's just say, ideas as to why, when they were working with these barometers, as to why the water was staying in the tube instead of running out. You'll see a very old barometer style here in a moment. And somebody finally suggested that this air that we breathe was pushing down on top of the pool of water, preventing all the water from running out of it. So we didn't always know this. All right, I'm jumping ahead of myself. I apologize. So air pressure, okay? The weight of a column of air on an area. Sorry to use the word area and air together there in the same sentence, but so the weight of a column of air. And in the Exploring the Earth chapter, way back in the beginning of the semester, we talked about this, okay? We talked about a 1-inch square column of air above you at any given moment, and depending on your elevation, okay, you had less or more air on top of you, therefore you had less or more air pressure pushing down on you. If you're at the top of a very high mountain, you were closer to the top of the atmosphere, so there was less air above you. If you were down at the bottom of a very low valley, you had more air above you, therefore you had more air pressure, remember? Okay. So they have to have a baseline, right? And that baseline is sea level for the most part. At sea level, all right, air pressure is 15 pounds per square inch, or 29.92 inches of mercury. And yeah, we all know how horrible mercury is to work with, and really don't do too much with mercury anymore. You could also measure this in inches of water. I just looked at it before I started this lecture, and I've just forgotten the height of column of water. It's easily Googled, but this conversation is all set up for inches of mercury, so we'll stick with it. But you could certainly do this with water as well. The idea is that this is all mercury. Okay, so you take a glass tube, you fill it up with mercury. This would be full as well. And then you turn it upside down into a little bowl of mercury. Some of the mercury flows out, but not all of it. And that's what was so perplexing to the early scientists. And what they realized, or came to realize, is that air pressure was pushing down on top of the mercury in the bowl, preventing the rest of the mercury from draining out. And when measured, it came to 29.92 inches. All right, and that has come to be known as standard atmospheric pressure. Depending on the humidity in the air, and a few other features, atmospheric pressure can increase or decrease, and that would make this level of mercury go up or down accordingly. It's pretty neat. All right, and as I said, the same thing works with water. Now, this is probably something you're much more familiar with. This is just a standard barometer that you might have on your wall. This works in an entirely different way. There's apparently a wire coiled up inside of it that expands and contracts based on the atmospheric pressure. I've not seen one of these taken apart. That'd be interesting to see. This I totally understand and get. Coiling of a wire, I can't quite picture that one. But again, even though it's not based on mercury, you see we still use the same calibrations. So we want to look for this 29.92 to be one atmosphere. And I'm not sure that I wrote that in here. Let's see. Yeah, I don't have that word in here. So this is also 29.92 inches of mercury. Is also sometimes called 1 atmosphere. And let's add that just for the hell of it here. 1 atmosphere. All right. All right, so 1 atmosphere, standard atmospheric pressure, barometers.